This is the last talk of EmberFest 2025. But nonetheless, it's Ed, so please, warmest and biggest round of applause. Thanks for being back.
Thanks. All right, hello and thank you. Last night I was talking to my wife Eileen and I said, I still don't have a fun intro for my talk. I like to put something fun in and not just make it all boring content. And she said, you need to tell them about the cat mayor election. And I said, you're absolutely right. I do need to tell them about the cat mayor election. So this story requires two little pieces of background information. And the first is that in the US, we have a kind of weird culture around political yard signs. Whenever there's an election coming, for months ahead of time, there's like signs all over the place for all the candidates and all the parties and all the causes. People put them in their yards, people put them out in public. And the second bit of background you need to know is that in the city I live in, Somerville, Massachusetts, right outside of Boston, there's this cat named Barry, he's widely recognized as the unofficial mayor of the bike path, since he's always greeting all the people there. And since we're having a real mayor election coming up, and there's all these signs about electing a new mayor, a challenger emerged. And along the bike path, this sign appeared. An orange cat is challenging our incumbent mayor for mayor of the bike path. And the incumbent, of course, could not just let this stand. So the incumbent soon had a sign also advertising himself along the bike path. And people thought this was really great and this was super cute. And it was so much less depressing than the rest of our real politics. So the idea started to spread. So soon we had a candidate entering from the Communist Party. And we soon gained other candidates like ones with ominous and ambiguous slogans. Is she against crime? Is she pro-crime? We don't know. Some of the candidates had really detailed policy platforms. Some of the candidates just really love puns. Some of them just don't seem like they're cut out for politics at all. Some of the cats really just wanted to show us that they disdain our human, puny democracy and know that they should rule over us. Some started running for entirely different offices than Bike Path Mayor. Soon other species wanted to get in on it. Some of the candidates just straight up would threaten you into voting for them. And some of the other threatening candidates had extremely good graphic design and cuteness despite their threatening aura. And we also had cats with really great names and slightly corrupt morals. And in the end, there were over 100 different signs all along the path with all these cats. And it was really just a spontaneous community art project that was just happened on its own. So it was really kind of fun. The winner, by the way, of the informally organized actual election was Minerva. So if you can now greet your friends in Somerville with Minerva, and they will just reply, crime. I'm going to bring Minerva back to help with my actual talk in a bit. So the way I want to structure this talk is I want to give kind of two smallish lessons about two areas in Ember that I see teams struggle with. I'm going to use those two things to connect them to one big overarching guiding principle. And the principle is the important part. I'm using these two examples because they're useful and you should learn them. But I'm also trying to use them to teach a bigger point about how we think about design and how we think about how we come up with good APIs that are going to serve everybody across the continuum in our community. So the two examples I'm going to draw from are test waiters and composing tracked state. And the overarching principle that I'm going to use to combine them is local reasoning. So by local reasoning, I'm talking about the idea that it should be possible to judge the correctness of some of your code by looking only at that code and the immediately surrounding local stuff. Right? So you probably already do a lot of things intuitively or consciously to help support local reasoning in your code. If you keep related things close together, if you limit the scope of your variables so they're not wider than they need to be, if you keep your functions reasonably small. All of those things help support local reasoning. And it's stuff that we all learn as we get better at development. But there are other ways that sometimes we don't notice we're breaking local reasoning. And a lot of those have to do with aspects of how time sneaks into our code bases. So for each of these examples, I'm going to kind of structure it by identifying the nice behavior that we want to get, the intuitively nice behavior, and how in order to get that, we need to maintain a global invariant across our whole application, but how we can achieve the global invariant by only using local rules. Right? So by global invariant, I just mean something that you can rely on being true across your whole code base, even without having to constantly think about it. You only have to think about the local rule that whenever I see X, I do Y. And if I follow that rule everywhere, it's going to imply something about my entire code base that's going to give me nice behavior. So that's very abstract. Let's take it to the first concrete example. And hopefully this is one that's not super unfamiliar to a lot of you. Though if it is, this is also a great little primer on what test waiters are. So when we write tests in Ember, these are examples of rendering tests. We've got a user badge component where we're just rendering it 2 different ways with 2 different arguments and asserting about what it does. And these are nice tests because we can just await render and then immediately assert. And our intent's very clear. This is a nice way to write tests. But the problem that can arise is that maybe your teammate goes and starts adding some features to this component. And they've changed it now so it does its own asynchronous data loading to find out facts about this user and figure out how to render them. And you notice that your test suite starts getting sprinkled with wait for or wait until calls all over the place. And not only do you see them on the tests that actually call this component, but you might see them on completely unrelated tests all over the place in the code base, right? Because some component is calling some component, which is eventually calling this component. And you've now lost your local reasoning in that test suite because you can't look at one test and immediately know if it needs this waiting or not, right? So that's an example of, oh, it feels bad to lose our local reasoning, and that's the problem that test waiters exist to solve. So, with apologies to Minerva, time is the source of most of what makes programming hard. It really is the recurring theme in the hard parts of programming. And in this case, what I mean by that is if there's asynchronous behavior going on in this component, all of a sudden, time matters in a way that it didn't before. We've got time-dependent values, right? We can't just on-demand compute exactly every fact we want when we want it. Some things we won't have till later. And so that asynchrony, that's fundamental to what asynchrony is. That's why asynchrony makes our code bases harder to deal with. Now, like the solution to our problem is, of course, I've already said in the title of this section, it's to use Ember test waiters. And so that's hopefully not a big surprise since I've been putting it in my title all along. But the key question is, where do you put it? Like, where do you actually need to put where do you need to register a test waiter? And how would you have a local rule so that in any PR you're reviewing from your colleagues, you would know they should have used a test waiter there, or no, they didn't need to use a test waiter there. So when we think about asynchrony is contagious, right? If your code suddenly needs to call some other asynchronous code, your code becomes asynchronous. And then all the people who call your code have become asynchronous, and it spreads. And so if you think about that, it forms a graph throughout your application, right? You have all these dependencies. I'm async because that's async because that's async. And this global graph is actually kind of hard to reason about. It could be really big and it could be really complicated. You don't want to have to reason globally about the whole thing. Instead, you want to notice that the graph has to bottom out somewhere at what I'm going to call the roots of the asynchrony. Right? There are some things that are asynchronous on their own, not because something else they call is asynchronous. Or what I mean is the thing they call is actually no longer your code. It's one of the few things that the browser gives you that are truly stepping outside of the JavaScript context and doing work that takes real time out in the world. So it's APIs like fetch, it's APIs like set timeout, also some of the kind of storage APIs like IndexedDB, all those kind of APIs where the browser itself is going to come back into your code at some later point in time, right? Those are the true roots of asynchrony. And all the other code that calls code that eventually uses these, that's not the roots. That's farther up the graph. And so And one exception to this would be if you've got third-party code that does some of these things, you aren't going to go into the third-party code to figure out where to put the test waiter. So you can treat those as black boxes. You could pretend that third-party API, right, is like another browser API, and think of it as one on this list. If you don't want to, if it's not your problem to go down inside that code base. So the takeaway is that where do you put test waiters? You put them at the roots of asynchrony, and that's the only place you need to put them, right? So in the case of this example, this hypothetical example, we'll say that there was a fetch call in that component. And so the edit to apply Ember test waiters in this case might look like this. This particular utility called wait for fetch in Ember test waiters is a relatively new one since before, it's after last EmberFest, so it's a this year kind of utility. It was part of the deprecate Ember fetch RC. And it's just a nice one to have because there's a generic wait for promise utility in here, and that might look like it would solve your problem. But you have to remember that the response you get back after you wait the promise still has asynchronous methods on it for getting the body of the request. So this utility takes care of all that. It ensures that all of the asynchrony is going to be registered with the Ember test waiter system. And the point of the Ember test waiter system is that there's a global settledness that you can wait for. And all of these utilities that we saw in the beginning, like click and render, they all automatically respect the settledness, and that's why we get the nice tests. So we've identified a local rule that we can apply when we're looking at our code base, when we're trying to decide how to make our own PR, when we're reviewing our colleagues' PR. We can look at fairly isolated chunk of code and make a decision, does this need to use test waiters? If it's a root of asynchrony, it should use test waiters. That's the local rule. That is what gives us a global invariant. And the global invariant's a little more complicated and subtle to understand. Right? It works because if all of my roots of asynchrony are registered with the Ember test waiters, all the other stuff that's derived from them, all those other async functions that call each other, all those are resolved on the browser's microtask queue. And the timing of that basically means that Ember test waiters can ensure that we get all that. As long as you have the roots, we can get all the rest. You don't have to be putting test waiters at every level around all that async stuff. So there's like two failure modes here. You could forget to put it on a root of state, but you can also unnecessarily put it all over the place in the code base. And that's not harmful, but it's just unnecessary code that you don't need. The really focused answer is to put it on the roots of state. So anyway, the global invariant is slightly subtle and complicated. And the point, though, is that as a user, especially a user who's just getting familiar with the intuitions and the paradigms, you just have to get familiar with the local rule and follow it, and then you get the nice behavior. And that middle step is what we build out as a community together with our shared expertise, right? But it's not something that you have to think about. You don't have to reason globally about your application. So this was my first example of local reasoning getting us nice APIs. So step into our second example, which is about composing tracked state. So this is about the question, what things should be tracked, and how do we compose tracked things together? Thinking back to our previous example with the test waiters, I said that asynchrony is contagious, but we can manage it if we found the roots of the graph. And tracked is very, very similar because trackedness is effectively also contagious. If you make some new state by making a getter that consumes some tracked things, everybody who consumes your getter, you're still trackable, right? The trackedness is contagious. And so just like in our previous example, we really want to identify the roots of state, and those are the things that get tracked. So if you think about the graph of dependencies in your application, just like with the graph of asynchrony, there are some things where it bottoms out. They're the things that don't have other dependencies. They are standing on their own as a piece of state that doesn't depend on another piece of state. Those are the roots of state. Those are the things that get marked with the @tracked decorator. And then all the other derived stuff is getters accessing that other stuff in as many layers deep as you want. Right? Getters, getting tracked. And that builds up the rich graph. And the rich graph can be complicated, and that's okay because you can reason about little pieces of it at a time. And looking at each little piece, you can still make sure it's doing the right thing. That's the concept of a local rule. So that was me describing what the local rule is in this case. And the global invariant that we get is that Glimmer is going to be able to know exactly which changes to track state might require it to update which parts of the DOM, right? You get those nice fine-grained updates. the intuitively nice behavior you get at the end is just, oh, everything re-renders automatically. Isn't that great? Right? And so again, we can teach people a local rule. This one's, I think, is a little harder to teach. I think, well, because we're going to get into the more subtle cases in a moment. I think the basic part of it is something people do get pretty good. Our basic teaching story around tracked illustrates this stuff, and people pick it up pretty quick. And once you have that, you get the nice behavior, everything re-renders automatically. The details of how it works, you don't need to know, but because we're looking out for each other as a community, we've got people with experience who help take care of that part, and you should absolutely level up in your understanding over time to be able to get to the point where you go through those phases Yehuda mentioned in the first talk. We've got a lot of callbacks here to the very first talk. I'm going to bookend this conf. As you move from a pre-rigorous intuitive user to a rigorous one to a post-rigorous intuition. So the hard part, I find a lot of people pick this up pretty straightforward. And if you do the simple case, you forget to use tracked, and you click the button and it doesn't re-render, people are like, oh, obviously I need to put tracked. Cool. And that tends to work out really good. I think it's a clear win in our API that people figure that out really fast. The harder part comes when people are trying to figure out how to compose state that's coming from different sources. So let's look at a real example that caused some trouble recently. This component is using an add-on called Track Toolbox, which is hiding some of the implementation detail. I'm going to skip into that in a second, but I wanted to show you the version using the add-on because it's a little declarative and it kind of conveys the intent of what this is trying to do. What it's trying to do is this is a component that takes in a source URL argument and it renders an image and it keeps track of whether that image has actually been loaded or not so that it could change the CSS classes. The point of tracked reset is that it's trying to make a tracked variable that is going to reset back to its default whenever this argument changes. So in this case, it says whenever the arg source changes, put is loading back to true. That's how this add-on is designed. That's not an endorsement. That's actually the source of the bug we're about to describe. So let me expand out what it's really doing inside so that we can talk about how it works. So this is the whole thing, flatted out as if you were not using an add-on. We've got, let's see, do I have a cursor? Yes, I do. Right, we've still got our is loading here. But what we're doing is every time somebody tries to access it, we check whether or not the source has changed from the last time we saw it. And if it's different, we reset our internal track thing to true, right? And then we're reflecting that out. So this has the behavior that I described. You've got a component that you can pass in a source. It'll eventually say loaded. And then if you change the source again, it'll go back to loading until our has loaded here fires again to get it back to false. So this component looked like it was working good. And it was in use for a while. And up through Ember 5.4, it was doing exactly what it wanted in an app. And then we got a bug report. It was actually Simon, maker of Ember Responsive Image, shared this example as a bug report. And trying to use this component on Ember 5.12, if you also happened to access the is loaded from a very specific syntactic position in the DOM, so it's a very sensitive bug, you could actually make this crash with a backtracking re-render assertion. So what I mean by backtrack and re-render assertion is the dreaded, you attempted to update this thing, but it has already been used in the previous computation, right? That exception. So did we violate our local rule here? Can we see what we might have done that would cause a problem? And let's draw our dependency graph here to think about it. So we've got two pieces of tracked state, and is loading depends on both of them. It's so far so good. This looks like a totally legitimate graph of the dependencies. The problem we have is that our internal is loading also depends on source, because changing source can change internal is loading, right? So we've added an extra edge to the graph now. And so what are my roots of state, right? My internal is loading is no longer a root, because roots don't have any dependencies, right? And so my rule got violated, and that ends up having bad effects. Looking more closely at what that means in the code, the core problem here is that we're reacting to a change in one tracked value, meaning when source changes, that's going to cause us to re-render. We're going to re-render. We're going to run is loading again from the template. is loading is going to come and then go and change internal is loading. So changing one tract causes changing another tract, right? That's an edge in our dependency graph that should never exist, because all of our tract things should be roots. Nothing changes them. They just are independent. They're independent sources of state, right? So this pattern is the thing that you can see, like, as a local decision looking at this code. You can look at this once you've learned the pattern and say, you've got a potential problem here because you're mutating a tract state from a getter, and that's not okay. So what it comes down to is it makes your code much more fragile and sensitive to precise timing. This happens to work for a long time because the timing was lucky. And then something in the Glimmer internals changed about the order it was pulling on pieces of your state, and we hit the bad path. Another way to think about what's happening here, if you want to reason about this and why this kind of pattern causes trouble, is loading appears in our template. So whenever we're rendering, is loading is going to run, this getter. And then when it runs, we might mutate our tract state internal is loading, right? And if that happens, Glimmer got through the middle of rendering somewhere, and then a change hits. And the problem with that pattern is that change could, like, the dependency graph is arbitrary and globally complicated, right? The fact that some tract state changes means lots of other stuff could be changing throughout the dependency graph, things that Glimmer has already consumed and printed out as part of the DOM. So in order to be correct at that point in time, it would either have to back up and redo it all, or it's got to give up and say, I can't do that, or it's got to ignore it and let it be out of sync. And you could get an inconsistent result where the same value rendered in two places on the page is different. So all of those are pretty bad outcomes. In very, very old Ember versions, we used to actually go back and re-render to try to make it correct. And it turned out that was a bad choice, because sometimes you'd have a bug like this and not notice till your phone caught fire from the constant loop of invalidations. Not really on fire, but you'd burn all your battery, that's for sure. And so way back around the Ember 2x era, this was first made into a warning and then made into a hard error. It's an error in development to warn you that it's happening. And in production, it's going to let you be inconsistent, basically. So anyway, that's why it is an assertion now, and that's the rationale behind that. So a better solution is to realize that we do need new tract state here, right? Because we know a new fact that nothing else in the app knows. We're the one who knows if that loaded event has fired. So we do need new tract state. But it's a root of tract state that's just ours. It's no other tract state affects it. It's our state, and it's a completely independent fact. It's not really related to the question of which source am I supposed to be loading. They're separate facts, right? I have tract state for which source am I supposed to be loading, and I separately have which events have I heard. And I could just keep those two sources of tract state separate. They don't change each other, but I could still derive the combined stuff in a getter. This is loading calculates the right thing, because what it's basically saying is if the URL I'm trying to load is different than the URL I've already loaded, I'm loading. And if they're matched, then I'm done loading. Right? So I think this is actually even a clearer piece of code than the original. For one thing, it doesn't hide complexity behind an add-on that you didn't need. It's just using standard tract. And then the usage of it here, because there's not an explicit mutation. The only mutation we have going on in here, right, is in our has loaded event handler. And that's another key local takeaway in terms of the patterns here. The healthy place to do mutations of tract things is in actions, action handling, event handling, the space outside of rendering, right? We kind of divide all of time into two categories. Right. Again, time coming and being the tricky thing. People get because time is such a trick. And I'm going to try to be a little more precise about what I mean about time being tricky in programming. Think about Microsoft Excel, right? Microsoft Excel is very, very good at what it does, and it empowers a ton of people who otherwise are probably not even coders to build pretty complicated stuff. And the reason they can do that is because it's a model of timeless programming, right? There's just values and formulas, and you can combine those up into pretty complicated stuff. And there's no, you wouldn't imagine stepping through the steps of Excel. That doesn't make sense, right? It's a timeless kind of a system, you don't think about when things update. There's just these relationships and they're timeless. There's no mutation happening inside of your code. Another word for that would be purely functional or side effect free code, right? And that kind of code is super easy to reason about. It's super easy to cache and optimize. So a lot of people love to try to write as much of that code as possible, and that's a great thing. The tricky thing is that real life ends up sneaking time back in, and so you need a balance in real applications. So this is where if you take the pure functional programming approach too far, you end up bending over backward to try to sneak time back in increasingly confusing ways. So I think in Ember, we've landed on a pretty nice compromise. We have this phase of time of the world when we are doing purely functional stuff. During render, think about your code like Excel. You've got your tracked cells that are just holding values, and you've got your formulas, which are the getters, deriving everything from them, right? And that's all. Now you don't care about what order Glimmer is going to update everything. You don't care about what order other changes might be hitting the application. You're much more robust because you just don't care about the timing. You can always get the correct value of anything in the system when you need it right at that time. But then we still can do mutation, right? Mutation, and what I mean by that is actually assigning a tracked value to something different than it was. Purely functional programming doesn't have mutation, and that's what makes it feel weird and awkward. And so it's nice to still have mutation too. In Ember, we get that, but we keep that in actions time. Right? So when the user clicks a button, we do it. Or another time is when something external, again, a root of asynchrony finishes, stuff has finished. Now it's okay. I'm outside of rendering time. That's when I get to do my mutations. So this shared intuition about when to do sets is when I think we can definitely teach better if we can kind of incorporate this story better into our materials. And it's also why obviously I made it part of this talk. So getting back to why this particular example component got an error on an Ember upgrade, that's never a good feeling. So I'm going to share an opinion about that, which this is not a vetted or has a consensus yet, but I think we probably should have a stricter assertion. Today, you get an assertion that says, you tried to update this thing after reading it. That's going to cause backtracking and bad things. I think we can make that a slightly stricter assertion and say, you tried to update this thing during rendering, full stop. Whether anybody tried to read it before or not is not really the relevant piece. So this would be definitely a change. It'd be something we'd have to let people opt into, because I don't doubt apps would suddenly hit this if we just suddenly introduced it as an error. But the point of this would be that you would notice these things earlier and be able to learn the patterns earlier and get better feedback earlier, and not break at some future upgrade when there's like this upgrade broke it because Glimmer's own timing changed. But you can also get these things, they're non-local failures, right? You could change code pretty far away in the application that happens to pull on something, that pulls on something, that pulls on something in a different order than before, and now you get the bug, right? So the point being, you just don't want to worry about the order things happen during render. You want to just be writing timeless code that doesn't care. So this is a summary of the two lessons we just went through with our local rules and how they imply a global invariant and the benefits you get from them. And I've added now a second global invariant to the bottom one here because we just talked about consistency with no backtracking is another benefit you get by following the rule that only the roots of state are tracked and everything else is a getter. As long as you follow that, you get those invariants and you get a good result. So what I want you to take away from this, well, in addition to the exact details of these things, which are useful, the big picture takeaway is that I want you to think back to Yehuda's talk at the very start of the conference. The left and the right columns here are examples of shared intuitions that we can teach to newbies to Ember and also really internalize as experts to Ember and just rely on them and be able to be effective without having to constantly reason about the rigorous reasons why, right? So this is like a core Ember value proposition that together as a community, we build out the complicated global invariant in the middle. And sometimes it's time when we're working on an RFC to go and dive into those details and make it really right. But when we're just trying to get stuff done and be productive and be empowering, you learn the patterns, which are hopefully all local patterns, so you don't have to think globally about an entire code base. And then you get the benefits and you know you can rely on them, and you've learned to come to trust them and feel productive and empowered. So this is hopefully a pretty good connection back to bookend our whole conference back to the things Yehuda talked about at the beginning. The other thing I want to say about local reasoning is that it does, of course, increase your odds of getting useful results from a large language model. And the reason I say that is today's models are extremely context limited. Like everybody's trying to make bigger contexts, and that's good. But there are pretty fundamental reasons why the performance between a really well-tailored small context query and a bigger nuanced context query, you're almost always going to get better reliability out of the smaller one. So smaller is better. And this is really not that different than optimizing for humans, because again, it's all about conserving attention, right? If the less stuff that the user has to think about when they're trying to figure out the right kind of code to write, the less things they have to pay attention to, the better for them. And the same is pretty much true of how much stuff you're going to have to feed to a model to ask it its opinion about what code you should be writing. If you can look at one snippet in isolation and say, oh, there's a root of state there and it doesn't have a test waiter, that's going to be much easier to detect than asking some model to crawl your whole code base, draw the whole asynchrony graph, and figure out if all of the nodes in it are covered, right? So another benefit to having nice locally scoped intuitions. And kind of a final thought on that intuition stuff, calling back to Yehuda's talk again, right? If we're going to develop together post-rigorous intuitions about the whole next era of software development, right? We need to move through those stages that he described together, where we start out just kind of trying things and following patterns, and then we get rigorous about figuring out what really works and why it works, and then we can move on to a post-rigorous intuition where we have a really good sense of when to use what tool, what's going to be effective. Using that rigorous stage to kind of weed out bad intuitions and foster our good intuitions. And so, of course, getting through that rigorous stage requires rigor and empiricism. And so I want to remind us as developers that we have pretty much two big blind spots that I want to highlight that get in your way when you do that work. And you could do that work much more effectively if you're aware of these blind spots. The first one is that we all suck at estimating. You are bad at estimating how long it will take to ship that new code feature. I am also bad at it. And I mean, if you're good at it, that's great, but then you're a real outlier. Or you're working on a feature that's like very similar to like 100 other features you've done before. I think as an industry, we are all generally still bad at estimating how hard things are in software and how long they're going to take. And there are fairly deep reasons for that. When you try to measure your velocity as an individual or as a team, we have to remember that velocity is not just a speed, but it's a speed and a direction. Right? And your direction in is my software project going the right way is a direction in a very highly dimensional vector space. There's a lot of factors you're trying to balance. So steering in the perfectly right direction is difficult. So that's partly why it's very hard for us to measure velocities effectively. What looks like speed might be speed taking you in a very wrong direction. So we need a lot more nuance there. So the takeaway from this part is that because we suck at understanding our velocities and our productivities, be suspect of subjective measures of velocity and productivity and which tools are giving you those things. You really need to get empirical on this stuff. And sometimes that's hard to do as an individual or a team. Like it's great to follow larger efforts to do research, to like follow up on literature, see what's going on in the industry, because we really do need science here and not just vibes when it comes to figuring out what's effective. And the second blind spot I want to highlight is that we all share a very, very deep cognitive bias. This is the famous face on Mars photo taken by the Viking 1 spacecraft in 1976. When this photo was published, a bunch of people went really nuts saying, oh my God, there's clearly aliens on Mars. They've carved this giant face in the desert. And it's just a really good example of how our brains are hardwired to seek out other human beings, to study them and see what they're thinking and try to model their internal state. It's pretty clearly a huge evolutionary pressure on our ancestors that if you were bad at understanding who was around and what they were thinking, you didn't do so good, right? It's like very critical social skill as a social animal. So we're so hardwired for this that we constantly anthropomorphize things, right? People see faces in their toast. People see faces on Mars. And people start to treat non-human things as human with very little prompting. And it takes very little for us to anthropomorphize things that don't in fact have any internal state. So when we're presented with a new thing like these large language models that do present some internal state and they do present a bit of human-looking stuff, that really tweaks out our cognitive biases. And it makes us very bad at judging what we're getting, both in terms of misunderstanding both the strengths and the weaknesses of the tool, because those strengths and weaknesses are alien to how we do it. Like, they're doing it a different way. They're going to have different strengths and weaknesses. And it's very hard for us to let go of our cognitive bias and judge it on its own terms rather than pretending it's a human. So my takeaway for you is be aware of your cognitive biases, act like a scientist, and let's do that together as a community so that we can keep our focus on being a community that helps people all along their path of learning. If they're just starting out with intuitively learning how to be productive with our tools, if they're starting to get into rigorously helping us evaluate how to be the most effective with our tools, or moving on beyond that to the time when they can just let go of the rigor and get into the flow and really ship great applications. So with that, I'm going to end my talk. And because you made it through all the talks, you will get one more cat as a treat. Thank you.
Thank you, Ed. Any questions or thoughts for Ed? Actually, let's plug in my computer while we let people think.
Sure.
I love the idea that velocity can't be measured in just one number, with this idea of it being multi-dimensional vector space. How do we convince CEOs and CTOs that that is true and to stop recording GitHub pull requests?
If I had an answer for that, man, I'd be a rich man, I think. No, I mean, we of course have to try. I do think that I reach back to the like original intent of something like the Agile Manifesto, right? Forget what people call Agile now, because it's evolved and mutated into lots of different things. But if you look at the original wording of that, bunch of people who came together to try to deal with dysfunction in our industry, what I read from that is you have to build trust with people, like especially like the business stakeholders that you're working for. You build trust with them by like continually showing real improvement day after day in ways that they can see, and finding a way to open your work up to them so that they are part of it and they see the progress happening. And when you build enough trust like that, the pressure to like hear long-term plans and long-term estimates gets less. It's not that you don't need any, because like the problem ends up moving. You might get the next level stakeholders. They're in there with you and they understand what's going and they feel like they have enough visibility, but now they've got to explain it to their own bosses, right? So it moves the problem around, but I do think that we build credibility by shipping early and often and being really transparent and being really adaptable, so that when like if we're doing really good at software engineering, we can steer and change better, right? Like that's the real question isn't like how fast can you ship 10 features? Like that seems like the surface question, but the real question is how fast can you ship the 11th feature after those 10 with the message you left behind, right? And like that velocity, that adaptability of having a code base that stays healthy because you care about it and act as a professional engineer who cares about the long term. That's what gives you the credibility to say, don't worry, like, look, we're doing good. We've got an estimate, but it's loose. And I have the credibility to estimate at a looser level. Like, I think the goal should be minimizing the amount of time you have to waste on excessive precision, right? I think if we try to calculate our predicted end date or our velocity out to 3 decimal places of precision, we're clearly kidding ourselves. But I think you can get a happy medium where, there's some of the systems people use are good ones. They're like, make it to the nearest power of 2 or whatever system you have, small, medium, large. Less precision is good because you can communicate the gist of things without getting bogged down in trying to precisely measure a thing that's extremely hard to measure precisely.
Thank you. Yeah, thanks, Ed.
Thanks.
Let's see if this works. Well, I'm not going to stand here by myself, guys. So, first, as already mentioned, the conference party will start pretty much now. Downstairs on the second floor, the signs will say foyer. It's much colder downstairs, promise, and the beer is cold as well. So there's that. But before we go, first of all, again, thanks to our sponsors, without whom this would not have been possible. We need a big round of applause for them. Also, to all our speakers, every single one, including the lightning talks. This was another wonderful year. Also to the staff, to Alex, you've been seeing him come around, take videos, take photos. It's been awesome. And most importantly, to all of you for coming and making this yet another wonderful, wonderful conference. And if you've been to EmberFest before, this would be when I say, let's go get a drink. But actually, there's some news. Well, because you may have heard us joke about that this may be the last year. We said the same thing last year about this year, so that didn't really hold true. But it has been getting increasingly more difficult, both in terms of the time commitment, but also financially. We mentioned that last year. As well. And so we weren't really sure what was going to happen this year. Obviously, I would call this a big success again. So again, thank you. But instead of saying this was the last year, we have some much better news. The team is actually growing. We have Annegret and Akansha joining us officially. I mean, you've known Annegret has been volunteering since, I don't know, ever, I guess, since the first year. But yeah, this will actually allow us not to do more of the work, but also have a lot more stability and hopefully security in organizing. That does come with a little caveat. We'll have Marco talk to you about that. But yeah, we are super excited having both of them join us going forward into the future.
Yeah, it's not really a caveat, maybe, but while it's great that we have more support, we still need all of your support as well, which means that we would really like you, and we need you to, when you go back to the office on Monday, to go to your decision makers and ask them to budget sponsorship for EmberFest in the next year, so we have enough money to organize the event. Right, so that would be really nice if all of you could do that, or maybe you're a decision maker yourself and can decide on the spot. That's even better. So yeah, please do that next week. But before you're back in the office on Monday, we're all still here, right? And we have the after party ahead of us. So let's go and celebrate.